Okay, welcome back to the optimization now. So here I've written optimal quantity, optimal price, and optimal contribution margin. So I've updated the graph over here, comparing it to the last video you've seen. The P function is the same. I've included in the marginal revenue function and included our marginal cost function. We're supposed to use the marginal cost in just a moment to optimize profits in the marginal method. Before we get to that, I'll just have some remarks about the functions here. So when you write in the marginal revenue, what you'll want to know and be aware of is that when P goes from flat to steep, then the MR will make a drop. It will have this like a drop zone of MR, and that is actually what question C is about, so I'll return to that and calculate it. But just so you know that if you substitute 12,000 into the MR1 function, you'll get one number, and if you substitute 12,000 into MR2, you'll get another number, and that's how you can calculate the drop zone. That's how you can see that it actually drops. Then we have the marginal cost up here. It increases and stems from the total variable cost. And that's actually the first thing we will want to calculate here is the marginal cost. So in the exam, we're given 0.02 q to the second plus 40q. So we're given this total variable cost function. We know it's a variable cost function because it has no constants. If it had a constant like, for example, plus 1,000, then we knew it will be a total cost function because the constant would be the fixed cost. So we disregard fixed cost here, or the baker doesn't have fixed cost. Either way, it's not relevant for this one. How to get the marginal cost is to differentiate the total variable cost. So I'll do that here. So marginal cost is differentiated. I differentiate the total variable cost according to Q. You can write it that way. Or you can write differential calculus in this way. So do whatever you please. These are the two normal ways of writing differential calculus. If you prefer this one, use that one or that one. So what we're going to do right now is to differentiate this function. So marginal cost, this function differentiated, 2 comes down. So it says 2 times 0.002, and we subtract 1 from the power. So that gives us 0.004q. And if I subtract 1, it just becomes 1. We don't write that. Plus 40q differentiated gives you 40. So plus 40. So we know now that our marginal cost function will start at 40 and increase with this slope. So making a graph like this in your hand or looking at what I've done in Excel is now relevant, because we can actually have 3 circumstances. We can have 3 different types of problems here. Problem 1, it can intersect at the lower bound, at MR2. Problem 2, or case 2, it can intersect in the drop zone. Or, as we see here, it intersects at the top MR1 interval. So how to see where it intersects, I'll return to that in question C, but if you make a graph here in your hand or in Excel, you'll be able to look at that illustration, and from that you can conclude, okay, then we optimize by setting MC equal to MR1. So when you do this at the exam, remember to write, because I can see that in my graph, it intersects in MR1, or just make an, you can say, make a reference to your illustration saying, I look at my illustration, I can see from the illustration that my optimum point, MR equal to MC, is there. Thus, I'm setting MC equal to the first interval of MR. Just write that into your exam so they know that it's not just like coincidence you set it equal to MR1. You thought about it, you evaluated it, and you are certain that that was the right intersection. So if we do that, it says, so the marginal revenue in that interval was minus 0.01 Q plus 180. I'm putting that equal to 0.004 Q plus 40. You can, for example, solve this using problem solver in Excel. You can use goal seek in Excel. I'll show you that later at the course. Or you can isolate it manually. That's up to you. Either way, do what you find easiest, do what you prefer, and check that you get the same result as I do. If I move this over at the left side, then I get minus 0.014 Q equal to minus 140. That's because 180 comes over at the right side, becomes minus 180, plus 40 is minus 140. So the optimal quantity will be minus 140 divided by minus 0.014, giving us an optimal quantity for the company of 10,000. So that will give us 10,000. We can just write that in now. So that is where we have our optimal value, and that is at 10,000. Now I can substitute my 10,000 into my P function. Remember, these are in thousands. I've written that in here. Now I can substitute the 10,000 into my P1 to get the optimal price. So the optimal price, again, optimal values, I give it a little star, then the one correcting your exam will know that this is not like a random p-value, this is the optimal price for the company. And that will be minus 0.005 times 10,000 plus 180. You'll find this function in question A, where I went through deriving P and MR. We'll find the MR function in question A also. So you have written these functions down. Now just substitute the 10,000 into those functions and I get an optimal price of 130. So that's up here. Then we're supposed to calculate the marginal contribution margin. So that is total variable cost minus total revenue minus total variable cost. You have two concepts to show how much the company earns at your exam. The one is profit, that is TR minus TC, and the other one is contribution margin, that is TR minus TVC. So the difference between profit and contribution margin is the fixed cost. So in profit, you also subtract the fixed cost, but in contribution margin, you only subtract the variable cost. That being said, in this problem, we don't have any fixed costs, right? So if we don't have any fixed costs, then contribution and profit is the same. So in this exam, that really doesn't matter because we don't have fixed costs. But I want you to be aware of it, because if you were given fixed costs, then it would make a difference if you subtracted it to get the profit or not subtracted it to get the contribution margin. So let's just calculate it here. So it's price times quantity. So our total revenue would be 130 times the quantity of 10,000. The total variable cost would be 0.002 times 10,000 to the second. I'm substituting into our TVC function up here, plus 40 times 10,000, 40 times Q, giving us 1,300,000. And down here, 600,000. Contribution margin, TR minus TVC equal to 700,000. So now looking at our exercise, it says determine the optimal price, check. Determine the optimal quantity, check. Determine the contribution margin, check. Always do a check like this when it's about the complex calculations, when it's about the complex models, because it's so easy to dive into a problem and almost forget what they asked for. For example, forgetting to calculate the contribution margin. That is so typical and is a very, you'll be so irritated on yourself if you hand in the exam and you talk with your fellow students and they say to you, oh, did you also get the 700,000 in problem with the king demand curve? And then you say 700,000, why? Yeah, you're supposed to calculate the contribution margin. And you're like, oh, I forgot. I only found the quantity and the price. And you'll be like, oh my God. You don't want to go there, right? So always do the check when you're finished. Check, 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 and then move on. In the next question, we'll return to this graph over here. We'll talk more deeply, thoroughly into the MR gap. So the MR drop. Why does it happen? And what can be said about it? And what is the drop zone in this case? See you in the next video.